Now here we are going to answer the question regarding convergence of this series. This series converges because it's what people call a P series with these powers. Sorry about that, because this power 4 is greater than 1. So whenever we have this, that if I have a series that looks like this, which is called a P series, then this series converges if and only if what? The power is greater than 1, and that's a consequence of what? The integral test for the P series. Okay, so by this criteria I just took this example that this is a convergent series. Okay, and the integral test applies on this convergent series. So what happens here is this, that here again the convergence is, or the series is, we have to determine that series is converging slowly or not. That's what we have to, or that's what we want to know. Okay, so if we added 10 terms, we'll get that. Okay, if we added say 20 terms, then what do we get? We get we get that it's still increasing slowly though. Okay, so let's see, we have to answer the question that how many terms should we add in order to obtain again a desired level of accuracy here. So see this, if I added only capital N terms, and again as in the previous video you saw capital N is 20 here and 10 is here, then what we are getting as our leftover, the leftover is we have capital N plus 1 to infinity, right? And this will be positive because all these terms are positive. So this value will be less than the integral, the improper integral, which is a convergent improper integral. Okay, that's how we concluded the convergence of this series. So that will be less than this improper integral, right? And that's what we got from the remainder theorem for a convergent series for which the integral test applies. Okay, so here we go. So this has to be less than that. So say we want to do this, that is, we would like to approximate uh, this with a sum of an error less than 0.001, then one way of doing that would be, we look at this and see which value will give us less than, which value of n will give us this integral less than 0.001. Okay, so let's quickly evaluate this integral. Okay, so if we want to do this, what we have is that let's write that in the in the ideal notation. Let's say we have alpha approaching infinity, and we, oops, sorry about that. Okay, so I'm writing alpha here, and then we have limit as alpha approaches infinity. All right, and then what is the antiderivative of 1 over x to the 4? We are looking at x to the negative 4, and which is going to give us what? 1 over negative 1 over 3 x to the which power? The third power, right? Okay, and then what we got is 1. Then we have this here. Okay, all right, so here we go. the upper limit is alpha and the lower limit is capital N. Alright, and so there we got this, and then we have negative 1 over 3 times alpha to the power 3. Okay, alright, and then we got what next? 1 over 3 times n to the third power, right? So as alpha goes to infinity, this will go to 0. So the whole thing equals how much simply? This. Okay. Now everything else will just be finding capital N so that this quantity is less than 0.001, which means what? That 3n cube, oops, sorry, that 3n cube is greater than how much? 1000, which is reciprocal of 0.001, which means that n cube has to be greater than 1000 over 3, right? Okay, and which means n has to be greater than the cube root of this quantity, right? Okay. So here actually we had a good situation that we could really, solve an inequality here. But if not, then we can look at a table of values, and we saw before also, that is when we were looking at going from 10 to 20, that we had seen a good approximation. So what you can say, that just adding 7 terms will suffice to get that level of accuracy. And then, well, let's just look at it, that how do we get this by adding only 7 terms. So here we go, we got that. Okay, let's add first 8 terms. Okay, all right, then we have that. Or let's also look at if it will give us. Okay, sometimes this package goes a little temperamental. Okay, even though it's a very good package. Okay, all right, so here we are. Okay, and I think this was 0.0007, and we just wanted 0.001, so that's working good enough. Okay, so I'm posting this script on our website. Let me know if you have any questions.